Hello and welcome to Day 1 Notes, Section 4.2 Operations with Matrices. To add or subtract matrices, they must have the same dimensions. So again, same size. If they do, you add or subtract their corresponding elements. So as shown before, if I have matrix A plus B, and to get the sum of those two matrices, you would take A, which is first row, first column, add it to D, first row, first column, the second matrix, and you get A plus D. You follow that pattern and you get your answer. Subtraction is the same. You would subtract the corresponding elements. So here if you have A and then D in the second matrix corresponds to that location, your answer will be A minus D. So let's go ahead and do the first example. We're going to find the following four. They gave us our matrices, A, B, and C. First thing we're going to do is find A plus B. So I would have 2, 3, negative 1, 7. And I'm adding to it matrix B, which is 6, negative 2, 4, negative 3. So again, I want to add corresponding entries. So my first entry here is 2 plus 6. That's going to give me my result, which is 8. 3 plus negative 2 is 1. Negative 1 plus 4 gives me 3. And finally, 7 plus negative 3 is 4. And that's all there is to it. Let's now look at B, which is we're going to take matrix C and subtract B from it. So again, matrix C is 5, negative 8. And we're going to subtract matrix B, which is 6, negative 2, 4, negative 3. Well, you'll notice that my first matrix is a 2 by 1. My second matrix is a 2 by 2. So because these dimensions are not the same, we are unable to subtract these matrices, so our answer would be impossible because they have different dimensions. Okay. Example 2 is one that I want you guys to try on your own, so go ahead and pause the video and check your answer with mine when you're done. Here are the answers to part A and B. If you did not get those right, please make sure to ask about those problems in class tomorrow. I do want to really quickly talk about the subtraction that you do in part A. As we all know, subtracting is the same thing as adding the opposite. So if I have something like 5 minus 3, it's the same thing if I add the opposite of 3, 5 plus negative 3. Both of those give me 2. So when you do have subtraction, a mistake that occurs frequently is that students will forget to subtract every one of the entries. So again, if you have negative 4, it's minus negative 5, turning that into a plus, and so on. What I like to do whenever I see a subtraction sign is instead of subtracting, I like to take this adding the opposite idea. So if I add the opposite of the second matrix here is a positive 5, negative 2, negative 9, and positive 3, and then you just add them. The last part of this lesson deals with scalar multiplication. You can multiply any matrix by a constant that's called a scalar. And when you do this, you're going to multiply every element of the matrix by the value of that scalar. So here we'd have K, that's going to be our scalar. A is our matrix. When you multiply it, it's just every single element inside of matrix A will get multiplied by that number on the outside. So let's do this first example. If Q is equal to 3, 4, negative 2, 6, 7, negative 9, we're going to find 4Q. So all we're going to do is put a 4 in front, write our matrix, and the result is going to be our matrix, but with every element multiplied by 4. So that'll give us 12, 16, negative 8, 24, 28, and negative 36. Example 4 has us combining both ideas from this section, addition, subtraction, and scalar multiplication. Here we're given matrix A and B, and we want to find negative 4 times matrix B minus 3 times matrix A. I'm going to go ahead and write that down. So my scalar in front of B is going to be negative 4. And I'm going to subtract 3 times matrix A, which is 7, 6, negative 5, and 2. I'm going to go ahead and multiply a negative 4 into every entry, giving me negative 12, 16, negative 4, positive 28, minus, now I'm going to multiply a 3 into the second matrix. It's 21. Okay, so now because I'm subtracting, I am going to do negative 12 minus 21 is negative 33. 16 minus 18 gives me negative 2. Negative 4 minus a negative 15 turns that to a positive 15, so it gives me 11. And then 28 minus 6 is 22. So again, with this problem, like I said on the front page, whenever I see this minus, and then whether there's a scalar here or there's not a scalar there, if I see a minus sign, I add, and then I'm going to add the opposite. So when I multiply throughout, I'm going to multiply a negative 3 to every entry of the second matrix. So then that would change the minus to a plus because I'm adding the opposite, and then it's going to change every sign in this second matrix. So positives become negatives and negatives become positive. And you'll notice that my entries in the result are still the same as they were before. So negative 12 plus negative 21 is negative 33, 16 plus negative 18 is negative 2, and so on. So again, when I see a minus, I like to add the opposite because then I'm ensured that I probably won't leave a negative out somewhere. Okay, so the last example here is one that I would like you to try on your own. Example 5, we're given matrix A, matrix B. They're both 3 by 2s. And we want to find negative 2 times matrix B plus 4 times matrix A. So pause the video and please do this problem on your own. Okay, here is the answer that you should have gotten. If you didn't, please make sure to ask your teacher in class tomorrow. Thank you. Have a great day.